So we'll wait for the few more minutes, then we'll start the class.
Okay, sir.
Those who have admitted from BSc, it's my request to all of you, you please collect the last two class note or basically the PPTs. I have taken two classes. All these are basically the basic background of the electromagnetic theory.
Okay, sir.
Today also I will discuss about the basic of that is the review of vectors and the review of coordinate system. Those who are from BSc, you are already familiar with the vectors as well as the coordinate systems. So I think there will be no need to repeat the last two classes for you. You just collect the PPTs from the rest of the student and go through the PPTs. If you have any problem, you can ask me. I will try to clear your doubts.
Okay, sir.
Because I in the last two classes I did not cover the syllabus basically. All those are the basic part of the to start the electromagnetic theory.
Okay, sir.
So already 22 have joined. I think now we can start the class. The PPT is visible.
Yes, sir.
So in last two classes we have discussed about the basically the basic overview why we need this particular course, what will be the benefit, and what are the different applications of electromagnetic fields and waves in different areas of the wireless communication that we have discussed, as well as we have discussed different historical background. Now today onwards we are going to discuss about the vector field. It's just overview of the vector fields which will be required to go through this particular course. Then we will discuss about the three different types of coordinate system and their transmission from one coordinate system to another coordinate system. Now during my class time, if you have any problem to understand any particular point, you should raise your voice. You can ask me directly. It will be better to clear your doubts. Okay, so as a review on vector field, we can start with this slide, because first of all we have to know what is scalar quantity, what is vector quantity. As you know, scalar means it has no direction, it has only the magnitude, whereas for the vector it has magnitude as well as directions. And scalar means it is basically the one-dimensional quantity, but in case of vector it is more than one-dimensional quantity. Next point, we can say that in case of scalar quantity we can divide it can be divided, but vector it cannot be divided. Next point, how we can represent a vector. If we consider a vector B, Bx is the component along x-axis, By is the component along y-axis, Bz is the component along z-axis, and this Ax, Ay and Az, these are the unit vectors along the corresponding axis. So we can write down the corresponding vector B equal to Bx Ax plus By Ay plus Bz Az. And what will be its magnitude? As you know, that will be root of Bx square plus By square plus Bz square. Next, what about the unit vector? Unit vector means that is the vector B divided by the magnitude. So it will be B by the magnitude of B. So by definition, the unit vector will, this is a small unit, this is a small vector along the axis, and it can be obtained by dividing this particular vector by its magnitude. So this B by root of bx square plus by square plus bz square. Now with this general idea, we are moving to the next point. Directly we will consider an example. Now you have to specify the unit vector extending from the origin toward the point G. That means you have to find out the unit vector for a particular vector which is extended from a particular origin to the point G equal to 2 minus 2, 1. How we can find out the unit vector? Just using the previous equation. So first we have to write down the corresponding vector G. So G will be 2 is the component along x-axis, minus 2 is the component along y-axis, minus 1 is the component along z-axis. So the corresponding vector G becomes 2ax minus 2ay minus az. What will be its magnitude? Obviously the root of 2 square minus 2 whole square minus 1 whole square, that is 3. So by equation, what will be your unit vector? The unit vector for the vector G, that's why we have written AG. AG equal to the vector G divided by the magnitude of the corresponding vector G. So that will be, if you calculate it, that will be the corresponding unit vector. So in that way, just with this simple example, I have tried to illustrate that how we can find out the unit vector for a particular vector. Next, we will consider the different laws of vectors. As you know, for a particular triangular laws associated with the triangle, we need to follow the head-to-tail rule. Head-to-tail rules means if you consider this is a vector, this is the tail of the vector, this is the head of the vector. The head of this particular vector A end at this point, and there is a starting of another vector, that is the tail, head, tail. But in that case, head to head. So we have to move from tail, head, tail, head in that way. Then in that case, the corresponding vector that is connecting this head and tail of the another two vector can be written as C equal to A plus B. However, in that case, you see, vector A started from this point, that is the tail, that is the head. B started at this point, that is the head, tail, that is the head. So from this point to this point. Now the tail and head of these two vectors are connected by the vector C. So for this two figure, we can write down that is representing the vector addition C equal to A plus B. But in this particular figure, if you consider to find out D in terms of vector A and B, if you apply this head to tail rule, vector A, B and vector D, this is the tail of the vector D, head of the vector D, tail of the vector B and head of the vector B. That means D and B will be added. So D plus B equal to actually A. So we can write down what will be the D vector. D will be equal to A minus B. In other way, you can represent the vector subtraction by just considering the reverse vector for a particular vector. That is, we can redraw this vector A in this opposite direction to represent its negative direction. Next is the parallelogram rule. If we consider one arm of the parallelogram, another arm of the parallelogram representing two different vectors, then the diagonal line will represent the addition of these two vectors. These are the two vectors along the one axis of the parallelogram. This is another vector. It is better to consider this figure. This is vector A, vector B. So the diagonal of this parallelogram C will represent the addition of these two vectors, C equal to A plus B, that is known as the parallelogram rule. Now in that case, it is representing the vector subtraction, as I have mentioned that to find out the vector subtraction, once again you can apply this parallelogram rule. So in that case, you have to extend the one vector in the opposite direction, that will represent the negative vector, negative B vector. Now if you draw a parallelogram considering these two vector A and vector B minus B, then the diagonal of this parallelogram D will represent the vector A minus B. Now we have to discuss about the resultant of two vectors. Now in this particular figure, we have considered two vectors A and vector B following their head and tail. So obviously C becomes C equal to A plus B. Now if this particular angle is theta, then it will be A cos theta, because this vector is A, so it will be A cos theta, it will be A sin theta. Now what will be this resultant vector C square? What will be the value of C square from this particular figure? You can use this particular equation to calculate the resultant vector of these two vector A and B. So C square means C dot C. C dot C means A plus B dot A plus B. So in that way you can find out that will be square plus B square plus 2A dot B. Now A dot B, that is we are applying now, we have to apply the dot product of the vector, though we did not discuss about the dot product, but as you know the basic of the dot product, so it becomes 2AB cos theta. In another way, by using the Pythagoras theorem, you can also find out the C square in this particular way. So by both way you can find out the resultant of two vectors, either following these rules or these particular equations, or using this Pythagoras theorem. Now we will discuss about the position and the distance vector. First, we consider the position vector. So in that particular figure, we have considered three orthogonal axes: x-axis, y-axis, and z-axis. We are considering a point P. This coordinate point is 3, 4, 5. Means along x-axis it is 3, 1, 2, 3. Along y-axis it is 4, 1, 2, 3, 4. And along z-axis it is 5, 1, 2, 3, 4, 5. So if you draw the projection on this particular xy plane, from this projection, or just to define the position of this vector, you can consider a vector from the origin to this particular point. It will represent the corresponding vector. So it is the vector RP. RP means OP. O is not shown in this particular figure, so it is basically the origin O. So the vector RP equal to OP. What will be its vector form? So obviously the AX is the unit vector along X. YAY, where AY is the unit vector along Y-axis, and ZAZ, where AZ is the unit vector along Z-axis. Now you just put the corresponding value. Along x-axis it is 3, along y-axis it is 4, along z-axis it is 5. So it becomes 3ax plus 4ay plus 5az. Now the question is how we can find out the distance vector, or what is the distance vector? It is basically the displacement from one point to another point. So if you consider two vector OP and OQ, OP and OQ means that is a vector RP, we can say. One can say this is OQ means RQ vector. Then what will be the RPQ? That is basically representing the PQ is representing the distance between 2 points. So it is representing the distance vector. So distance vector RPQ equal to, using the triangle rule or head to tail rule, you can write down that RPQ equal to RQ minus RP. RQ এর মধ্যে কি what are the different components in RQ? That is the XQ, YQ and ZQ. What are the components in RP? That is XP, YP, and ZP. So simply the vector subtraction, applying the vector subtraction rule, it will be XQ minus XP into the unit vector along x-axis, YQ minus YP into the unit vector along y-axis, then ZQ minus ZP into AZ, that is the unit vector along z-axis. So in that way, we can find out the distance vector between 2 points. Now, from this particular example, it will be more clear. So we have considered 2 points P and Q. P, the coordinate of P is 1, 2, 2, 3. The coordinate of Q is 2, minus 2, 1. The figure is drawn accordingly. That means along P is represented. Along y-axis it is 2. You see along y-axis it is 2, and along z-axis it is 3. Along z-axis 1, 2, 3. So that is the point. This is representing the point 1, 2, 3. Similarly, it is representing the point 2, minus 2, 1. Along x-axis it will be 2. Along x-axis it will be 2. Along x-axis it is 2, 1, 2, 2. Then along y-axis it is minus 2. Along y-axis it is minus 1, minus 2. So that is the point. And along z-axis it is 1. Now once again, applying the same rule, RPQ, what will be the distance vector between these two vectors or 2 points P to Q? That is RPQ. As the vector is directed in that direction, that is from P to Q, so the corresponding distance vector will be written by R. First you have to write P, then you have to write the Q. Then by using the triangular rule, you can write down that RPQ equal to RQ minus RP. Then just the points are given, you can easily find out the corresponding distance vector. Now, in case of polygon, that is number of lines is more than 4 for any arbitrary shape. We have to move in a particular circular path. We are considering different vector A, B, C, D. Now you see the direction of vector D is in opposite direction. Similarly, vector E is opposite direction. Now we have to start from a particular point and we have to end our movement at the same point. So that means if we start from this point and we move clockwise, then we have to move in that way. But at the same time, if we move anti-clockwise, then that will be different. So we are moving in that direction, in clockwise direction. Then what will be the corresponding resultant vector? Vector A, vector B, vector C. All these are in the same direction, A, B, C. However, vector D and E are in opposite direction of our rotation. So it will be minus D, minus E. So the total will be 0. Now, depending on the previous discussion, I have considered some problems. These are basically for your homework purpose. Hope you will try to solve these problems. I'm not going to discuss about the solution of these problems. I'm leaving it as a homework. No need to copy it or no need to take the screenshot or snapshot. I will send the PPT at the end of the class. So try to only concentrate on the class, whatever I am saying or whatever I am trying to discuss. In that case, it will be better to understand. Next, we will discuss about the dot product. If we consider any two vector, vector A and B, and the angle between these two vectors is theta AB, then as per the dot product, A dot B will be mod of A, mod of B, cos theta AB, where theta AB is the angle between two vectors A and B. Now we know that the dot product of two vectors will be always a scalar quantity. Now if we consider two vector A and its corresponding coordinate point is ax, ay, az, similarly another vector B, its coordinate point is bx, by, bz, then what will be A dot B? Then simply A dot B will be ax, bx plus ay, by plus az, bz, and that dot product will be a scalar quantity. Now if we consider the dot product of two vectors, where the two vectors are orthogonal with each other, orthogonal to each other means they are perpendicular with each other. They are perpendicular with each other means what will be the value of theta? What will be the value of theta?
90 degree.
90 degree. Now in this equation cos 90, you know cos 90 is 0. So A dot B will be equal to 0. So the dot product of two orthogonal vectors will be always 0. Now we will discuss about the some laws associated with the dot product. First is the commutative law. Commutative law means that is A dot B equal to B dot A. That is reverse is also true, which is not true for the scalar product, cross product. But in case of dot product, they are basically the commutative in nature. Now dot product is also distributive in nature. Distributive in nature means if A dot B plus C, then you can easily write down that A dot B plus A dot C. And if you perform the dot product between two same vector, it will be square. Now others laws you can say that is ax dot ay dot az, az dot ax. What is ax, small ay? These are basically the unit vector along the corresponding axis, and we have considered basically the orthogonal coordinate system where x, y and z are perpendicular with each other. So if you find out the dot product between these two unit vector along x and y, along y and z, along z and x, they will be always 0. Now what will be the dot product between the same unit vector? Using that will be equal to 1. As we are considering it is unit vector, so it will be 1. Next come to the cross product. Once again, if we consider two vector A and B and their cross product, that is two vector A and B, theta AB is the angle between these two vector, and we are curling from A to B. That's why the arrow in this particular angle is drawn from A to B. That means it is representing that we are curling from A to B. So in that case, it is better to use the right hand screw. That is if you move a screw from A to B, it will move into the paper. Okay, so that is the direction of the corresponding cross product. So for this particular cross product, it has also some direction along with the magnitude. So the cross product of two vector will be always a vector. So we can write down that A cross B equal to mod of A, mod of B, sine theta AB, and what is AN? This AN is the unit vector along this cross product. This AN is the unit vector that is normal to the plane containing A and B. Normal to the plane means this is the plane that is represented in a shadow format. So the unit vector will be normal to this plane. That means the unit vector is along this direction. So N is the unit vector that will be normal to the plane containing the corresponding vector A and B. Now, how we can find out what will be the direction of this unit vector? We can find out it with following the right hand thumb rule. Right hand thumb rule I will represent it. It is represented in the next slide itself. So I'll discuss at that time. Now, if you consider two vector with their coordinate ax, ay, az, vector b with coordinate bx, by, bz, then what will be the a cross b? We can write down it in this type in this particular matrix format. So from this, the corresponding a cross b will be this. Now, in that case, that will be ax is the unit vector along x-axis, ay is the unit vector along y-axis, and az is the unit vector along z-axis. Now, this is the right-hand rule. This is presented in that particular pictorial form. What will be the direction of your unit vector for the cross product? This is a vector A, this is a vector B. You are curling from A to B. So you have to close your fingers of the right hand from which vector to the another vector you are curling. That is, you are curling A to B. So you have to curl from A to B, or you have to close your fingers of the right hand accordingly. Then your thumb will represent the direction of the unit vector. That is also the same thing. That is, it is representing the right hand screw from your curling from A to B. Then the screw will move in that particular direction. So using this right hand rule, you can easily find out the direction of the unit vector after the cross product. Now we can also find out the cross product using this cyclic permutation. Cyclic permutation means this is ax, ay, az. Now, if we move clockwise direction, it will lead to a positive result. Now, if we move anti-clockwise, this is the vector ax, sorry, ay, with unit vector ax, vector az. So, if you move clockwise, it will be the resultant will be a positive. If you move anti-clockwise, counterclockwise, that will lead to a negative results. Now we'll consider the properties that are associated with the cross product. Unlike the dot product, this is not commutative. Not commutative means the reverse is not true. That is, A cross B not equal to B cross A. Rather, it is anti-commutative. Anti-commutative means that is A cross B will be equal to minus of B cross A. It is not associative. It is not associative means you can't write down any vector by just changing its position. That is, say if A cross B cross C, then you can't write down in that form. Rather, it is distributive. So if A cross B plus C, you can write down A cross B plus C equal to, in that way, A cross B plus A cross C. So the others law, then that means it is very important to consider the cross product between the unit vectors along the corresponding coordinate axis. Ax, Ay. That means you are considering the cross product between the two unit vector along x-axis, another is along y-axis. So it will move along z-axis. You are curling or crossing from x to y. So it will move towards z, positive z direction, that is az. Similarly, y to z. If you curl from y to z, then it will move towards the x-axis. And if you curl from z to x, it will move towards the y-axis. So it will be ay. And the cross product between the same vector, it will be 0, because for a same vector, the angle is, what is the angle? Angle is 0, sine 0 is 0. So A cross A will be equal to 0. So these are the basic discussion regarding the dot product and cross product. Apart from these basic rules, we have to also go through some basic equation rules of the cross product like this one. That is, if we consider the triple product A cross B cross C, I will not discuss or I will not move to the proof of this type of equations. Like you have to memorize it to apply in different to solve the different problems of electronic theory. That is A cross of B cross C. You can write down B A dot C minus C A dot B. It is better to remember it in that form, BAC minus CAB. Okay, with this particular rule, you can. It is easy to remember this particular formula. That is A cross B cross C equal to B of A dot C minus C of A dot B. That is BAC minus CAB. It should be also noted that if A dot B into C, that is not equal to A into B dot C. But you can write down just changing the position of the product of C. So A dot B into C, you can write it C into A dot B. There is no problem. Now, if you consider the scalar triple product, that is A dot of B cross C, that becomes B dot of C cross A. That is equal to also, you can write down C dot of A cross B. Now, this triple product is basically a scalar quantity. You can also find out from this matrix representation what will be A dot of B cross C. So, it is basically the dot product. B cross C is itself a vector. A is vector. So, dot product of two vector. What will be the dot product of two vector? It will be vector or scalar. Simply, it will be scalar. That's why the triple product of scalar is a scalar quantity. Is it clear? A is vector, B cross C, it is the cross product of two vector. The cross product of two vector is nothing but a vector. So in that case, basically we are performing the dot product of two vector. So it will be always a scalar quantity. Now that is very also important. That is the projection of vector, or you can say the component of a vector. Now this projection or component of vector may be represented as a scalar as well as a vector quantity. First, we will consider how we can represent the projection of a vector and how it can be represented by a scalar quantity. Then we move to the next one. So if it is a scalar quantity, say this is a vector A, the projection of this vector A on another vector B, So the projection of this vector B, A means that is this part only, that is represented by AB. So what will be the AB? We can write down AB equal to A of cos theta B, A of cos theta B. This is nothing but a scalar quantity. Now this A cos theta, this A can be written as in this particular form, A into AB, where A is the magnitude of the vector A and sorry, AB is the unit vector along this vector B. So that AB becomes A dot of AB. If we consider this is a vector, sorry, not a vector, in that case it is a scalar quantity. So that becomes, what is A into AB cos theta? A into AB cos theta means that is the dot product of A and the unit vector along the vector B. So it becomes vector A dot the unit vector along B. So what about this AB, the component of vector A on the vector B, or the projection of vector A on sorry, on the vector B, that AB becomes A dot of AB. Now this is a dot product. So in that case, the projection of vector A on another vector B, it is represented quantity. Now in another example, we will show that we can represent this projection or component of the vector by a vector quantity itself. same thing. We are considering a vector A, another vector B. Now we consider the projection of this vector on this particular vector B, that is vector AB. In that case, it is represented in terms of vector. That's why it has some direction. But in that case, AB, it was not a vector. That's why you have used two arrow on this particular line. Now, why in that case it is represented a vector? It will be clear. Now, how we can write down this AB? But at the same time, if you consider this particular triangle, how you can write down this particular one? It will be A minus AB, because head, tail of this vector. So AB plus this particular unknown vector equal to A. So this unknown vector becomes vector A minus AB. So we can write down this AB vector. AB is now a vector. AB equal to the vector magnitude AB into the unit vector along the corresponding vector B. AB. Now what is this AB? How you can find out this AB from this equation? How you can find out AB? AB equal to A into AB. That is the dot product of this particular A and AB. So the representation is still a vector because AB is a scalar quantity, but this AB is the unit vector. So this particular representation, in this particular representation, AB is representing a vector. That means the projection of a vector, the component of a vector on another vector can be represented either in terms of a scalar quantity or in terms of a vector quantity. In case of scalar quantity, it will be A dot of AB. In case of vector representation, it will be A dot of AB into the unit vector. Is there any doubt?
No, sir.
Okay. Now, once again, depending on some previous discussion, I have considered some problems for your homework purpose. One minute.
Hello, sir.
Yes.
Sir, I have a slight doubt from the previous slide.
Yes, you can tell me.
So, if it is a vector quantity, like if we are considering it to be a vector quantity, then we are not like it's the projection is happening on a vector. Like A is a vector, B is also a vector, and the projection is happening
Yes.
happening on a vector. So at that time, we are considering AB to be a vector quantity.
Yes.
But in case of the scalar, at that time we are not considering AB to be a scalar quantity, vector quantity.
No.
So it's completely on us that what we want to consider the projection vector to be. Like if we want it to be a vector quantity, then we will consider it to be a vector quantity,
No.
or else it will be a scalar quantity.
No. Point is that projection, if you want to represent the projection of the component of a vector on another vector, you can represent it in terms of a scalar quantity or in terms of a vector quantity.
It depends on us, like it's or the requirement of the question.
Yes, yes, yes.
Okay, that was my query. Thank you, sir.
Next, we are moving to the coordinate systems and the transformation of different coordinate systems from one coordinate system to another coordinate system. So, as you know, we have to basically deal with three different coordinate systems. The Cartesian coordinate system, where the particular point is represented in terms of x, y, z. That is three orthogonal coordinates system. X, y, and z, three orthogonal axes. Next is the cylindrical coordinate system, that is represented in terms of the radius of the cylinder rho, phi is the angle, and z is the height of the cylinder. And another important coordinate system that is known as the spherical coordinate system. Here we basically represent a particular point in terms of r, theta, and phi. So one by one, we'll discuss these three different coordinate systems. First, we start with the Cartesian coordinate systems. So it basically consists of three mutually orthogonal axes. Three mutually orthogonal axes means if we consider this is the origin, that is O, axis X, axis Y, and axis Z. So these three axes are mutually orthogonal to each other. Now, considering these three orthogonal axes, we can consider three different planes. One is XY plane, one is XY plane. On this XY plane, what will be the value of Z? The value of Z is 0. So it is also called the XY plane or ZO plane. Next, we can consider this is another plane, that is YOZ plane. YOZ plane. On this YOZ plane, what is the value of X? X equal to 0. So it is also known as XO plane or X equal to 0 plane. This is the another plane. This is known as XOZ plane. XOZ plane. On this plane, what is the value of Y? The value of Y equal to 0. So this particular plane is known as Y equal to 0. So in this Cartesian coordinate system, so we are basically considering three mutually orthogonal axes X, Y, and Z, and a particular point P at any point at any position is denoted by X, if we consider P at this position, P can be represented as X, Y, Z. Now, how we can mark the position of any point on this particular Cartesian coordinate systems? It is basically defined by the intersection of three planes. So if you consider 2 points, first you consider P equal to 1, 2, 3. Try to find out the point 1, 2, 3. This is x-axis, this is y-axis, this is z-axis. One small unit means 1. So as per this, P equal to 1. So along x-axis it will be 1. Along x-axis it will be 1. You see, along x-axis it will be 1. So this is the corresponding value of x. Next, you consider the point x equal to 2. Y equal to 2. Y equal to 2. Y equal to 2 means 1, 2. So this particular point. Now you move to this point. That is z equal to 3. So the intersection of this three plane will be at this position 1, 2, 3. So a particular point in the Cartesian coordinate system is basically represented by the intersection of these three planes. Similarly, you can find out the location of this particular point 2, minus 2, minus 2, 1. Along x-axis it is 2, along y-axis it is minus 2, and along z-axis it is 1. So the cross section of this three planes will be at this position. Q equal to 2, minus 2, 1. Now we have to consider the unit vector at this particular point. In Cartesian coordinate system, it is very easy to realize the unit vector at a particular point, because these three axes are orthogonal to mutually orthogonal to each other. So you can easily find out the corresponding unit vector. So this is, suppose this is the sample point P with some coordinate is x1, y1, z1. If you draw the projection, that will be the x1. So this is the x1 value. This is the y1 value, and this is the z1 value. So the unit vector along x, it will be along this x, along that direction. Unit vector along y-axis, that is AY, will be along y-axis, and unit vector along z-axis, it will be along this direction. So to determine or to detect the direction of unit vector, first you consider that particular point, and hello, am I audible? Hello. Okay. Next.
Yes, sir.
Okay. Then you just increase that coordinate value along the corresponding axis. That means you are at point P. Now you have to, if you have to determine the direction of unit vector along Y, what you will do? You just increase the coordinate value along this particular axis. So that will be the unit vector along Y axis. Similarly, you are at this position P. Now you want to find out the unit vector along X axis. So you increase the coordinate value at this point, and that will be the direction of unit vector along X axis. Similarly, you can find out the direction of unit vector along Z axis. So it is very easy to determine the direction of unit vector at a particular point in the Cartesian coordinate system. So at a particular point P, when we are increasing the coordinate value in a particular direction, we are getting the unit vector. Now, if we consider the differential increase, suppose P at this position, this is the corresponding position P. Okay. Now, that is the differential increment along x-axis dx, differential increment along y-axis, that is dy, and differential increment along z-axis is dz. So at point P, now we are differentially increasing the coordinate values at the point P. So what will be the corresponding value of the new point P dash? Actually, P is at the other point, at the other end, which is not visible in this particular figure. P dash is the extended point. So the coordinate point of P dash becomes x plus dx, y plus dy, and z plus dz. So what will be the volume of this particular box, rectangular box? That will be dx, dy, dz. What will be the area of this particular surface? You see, it is along the y-axis and z. It is basically yz plane. It is basically yz plane. So along on this yz plane, x is 0. So what will be its area? dy dz. What about this particular plane? This is basically the xz plane. You see carefully. You see it carefully. It is basically the xz plane. So the incremental area will be dx into dz. What about this particular plane? It is basically this particular plane means this one, xy plane. Xy plane. So its surface area will be dx into dy. So that is mentioned in this particular point. There are 6 planes. Total volume will be dx, dy, dz. The 3 surface area of the differential area is dx, dy, dy, dz, and dx, dz. What about the incremental length? It is directly dx, dy, and dz. Along x-axis, it has been incremented by dx. Along y-axis, it is incremented by dy. Along z-axis, it is incremented by dz. Now the surface, if you consider this is the small volume with side of dimension dx, dy, and dz, these are the incremental. So the corresponding surface you have to consider one by one, and the differential surface dy dz, this is the yz plane, sorry, xz plane. This one is the xz plane, dx dz. Now what will be the normal unit vector? Unit vector means what is how you have defined the unit vector? A small vector that is normal to this surface. So if you draw a normal to this particular xz surface, this small surface xz, dx, dz, it is nothing but this plane, xz plane. Now what will be the direction of unit vector for this particular plane? Someone please tell me.
Along y-axis.
Along y-axis. How you will be able to find out it? You have to draw the normal on this plane. Normal to this plane means that is a perpendicular line to this plane. It is nothing but along y-axis. So if you consider this incremental surface by a vector d of sy, so you have to multiply it by the unit vector along y-axis ay. So that is dx dz ay. I think this is this one, second one. D of sy. This is the vector surface on yz plane, xz plane. So dsy equal to dx dz ay. Similarly, for this particular surface, it will be a vector along z direction. So it will be d of sz. What is the incremental increment in the dimension? Dx into dy. The unit vector is along z direction. So this is equal to dx dy into z. Similarly, you can write down these three differential surfaces along with their unit vector. This suffix depends on the direction of the unit vector. As the unit vector is along x-axis, so it will be d of sx. As this unit vector is along y-axis, so it will be d of sy. For this one, it is z-axis, so it will be z. So with this basic idea about the Cartesian coordinate system, now we are moving to the circular cylindrical coordinate system. Okay, it basically formed by three surface of three planes. A cylindrical coordinate system is basically formed by three surfaces or three planes. One first plane, that is, you can say that is the plane of z, where the z value is constant. And another one is the cylindrical, you have to consider a cylindrical surface. The center of the cylindrical surface will be at along the z-axis or on the z-axis. The radius of the corresponding cylinder will be rho. So we are considering a cylinder whose center, or you can say the center line of the cylinder is along the z-axis. Radius of the corresponding cylinder is rho. So first we have considered a plane with a constant z value. That is, you can say that is the top or bottom of the cylinder. This is the outer surface of the cylinder. That is another plane. And another plane that is perpendicular to the xy plane and rotate about the z-axis by an angle of phi. So apart from these two planes, that is the top and bottom of the cylinder and the surface of the cylinder, we need to consider another perpendicular plane that is the xy plane. And if you rotate it along the z-axis by an angle of phi. So these are the three planes consisting the cylindrical coordinate system, and these are the corresponding unit vector along the corresponding plane a rho, a phi, a z. So in a cylindrical coordinate system, any point is represented by rho, phi, z. It will be more clear with the next picture. Try to identify the three planes first. First one is this plane. What about this plane? You can say this is the top of the cylinder. This is x-axis. This is y-axis. This is z-axis. You have considered one cylinder with a radius of rho. The center of this cylinder is along z-axis. Center of the cylinder is along z-axis. So first, to visualize the cylindrical coordinate system, first you just try to consider a cylinder that is placed and its center is along the z-axis. The radius of the corresponding cylinder is rho. Now we consider the top of this cylinder. It is better to consider some container. This is the top of the container. This is the bottom of the container. What about this particular plane? On the top of the container, if you consider the plane with this particular cut, what will be the value of z? Z will be constant. So on this plane, Z is constant. Whatever be the position of this particular plane, at this position, Z will be constant throughout the plane. Now you need to consider the second plane. What about the second plane I have mentioned? That is this one. This is the surface of the cylinder, the surface of the container. The third plane that is considered as the plane perpendicular to the XY plane. What about the XY plane? This is your XY plane. This is your XY plane. So another point, the previous plane that I have mentioned, that is the surface of the cylinder. On the surface of the cylinder, what should be the value of rho? What should be the value of rho? Rho, that is the radius of the cylinder, so it will be constant. Next, come to the third plane. Third plane, that is a plane perpendicular on the XY plane. That is a plane perpendicular on the XY plane, that is passes along the Z axis, and you need to consider the angle from the X axis, this particular angle. So we are considering a perpendicular plane on the XY plane, and we need to consider the rotation of this particular plane from the about the Z axis. This particular plane is rotating about the Z axis, making a particular angle of phi with axis X. This is the angle is making by this particular plane. So in that case, the cos any point P. So at this particular point, we have considered three planes. One is the constant Z plane, that is, you can say, the top of the cylinder. Another plane we have considered, this one is the another plane, that is the surface of the cylinder with a radius of rho. So on this particular surface, what should be the value of rho? Rho will be always rho will be always constant. And at this point, we have to consider another plane which is perpendicular to the XY plane, and it is rotating. The plane, you can consider this plane is a rotating plane. The rotation is about the Z axis, and the angle of rotation you have to measure from the X axis. So from X to this plane, the angle is phi. So this particular point P is represented by rho phi and Z. So the particular point for a particular cylinder, rho is constant. The Z, this is also constant, and on this particular plane, phi is also a constant. Is there any doubt regarding the basic idea about this cylindrical coordinate system? We are considering three planes. One is the top or bottom of the container. Another plane is the surface of the container. And the third plane, that is the imaginary plane, which we are considering, that is perpendicular on the surface, and it is rotating about the center of the container, making an angle phi with the x-axis. So in the cylindrical coordinate system, we can represent a particular point P by rho phi Z, where rho is the radius, Z is the value along Z axis, and phi is the angle of the plane of rotation, that is the angle made with the axis X. So the same kind of illustration, just to show the unit vector, three different unit vector. You see, we have considered one cylinder. Center line is along the Z axis. Center line is along the Z axis. The radius of the cylinder is rho 1. Now we have considered a particular point P. So through this particular plane, first of all, you need to draw one imaginary plane, which is perpendicular on this xy plane, and this particular plane made an angle of phi or phi 1. In that case, we have represented this by phi 1. So it is phi 1. So the point, this particular point P, can be represented by rho 1 because rho 1 is the radius. Phi 1 is the angle of this particular perpendicular plane, and Z is the height of the cylinder. Sorry, Z1 is the height of the cylinder. Now to the same rule to find out the unit vector at this point. How you will be able to find to direct the unit vector, or how you will be able to draw the unit vector? কি বলেছিলাম কিভাবে ড্র করা যায়? You just extend the corresponding axis by a small amount. So rho, this is the radius of the cylinder. So the unit vector along this rho, you have to extend this particular line. That unit vector will be along this direction. Sorry, the arrow will be along that direction. So it will be the A rho. A rho is the unit consideration of this A rho and AZ is clear, because AZ is nothing but just extend this particular Z along the Z axis. It will represent the Z. But what about the A phi? Phi is basically representing this plane. So you have to draw a normal. On this particular plane. The imaginary plane that you have considered, on this imaginary plane, you have to draw a perpendicular or normal. Then it will give you the normal vector along for the phi. So that will be the normal vector for the phi. Is there any doubt regarding the three normal vectors for this cylindrical coordinate system? Simply the normal
No, sir.
unit vector means the normal to the corresponding plane. Okay. Now, if you have to find out the normal vector for this rho means the rho is responsible for which surface? Rho is responsible for the surface of the cylinder or the surface of the container. So to find out the unit vector, you just draw a normal to this surface. So if you draw a normal on this surface of this container, it will you have to draw in that direction. Next, the Z, the unit vector along Z. For the Z, which is the Z axis, which particular plane or surface is responsible for the Z? The top surface or the bottom surface? So, but basically on this particular surface, Z is constant. So this surface is responsible for the Z coordinate. So to draw the unit vector, you just draw a normal. Normal means a perpendicular to this particular plane. So whatever plane we have mentioned, three different planes, one with Z constant, one with phi constant, another with rho constant. For rho, this is the plane. This curved surface is the plane corresponding to the rho. Okay. Next, so you draw a perpendicular or normal to this surface. It will represent the arrow. Next, what about the another surface? That is the surface with constant Z. That means this particular surface. This particular surface. So to find out the unit vector, you draw a perpendicular on this particular surface. So that will be AZ. Next plane is the plane perpendicular to the XY axis. That is this imaginary plane. This is the imaginary plane. that can rotate about the z-axis, and it makes an angle of phi. So on this particular plane, phi is constant. So now to find out the unit vector for this particular plane, you have to draw a perpendicular or normal to this plane. So this is nothing but this one, a phi. So in that way, you can easily find out the normal vector for three different planes. That will be a rho, a phi, a z. Apply the rules of the basic dot product. So what will be the a rho dot a rho, a phi dot a dot a phi, a z dot a z? That will be always 1 because they are unit vector and you are dotting with same unit vector, so it will be 1. If you consider the orthogonal combination, a rho dot a phi, a rho dot a phi. The angle between these two unit vector is 90 degree. Similarly, a phi to a z, similarly a z to a phi, they are orthogonally perpendicular with, mutually perpendicular with each other. So all this dot product will be 0. Now just a cross product, a rho cross a phi, a rho cross a phi, a rho cross a phi. If you curling from a rho to a phi, it will move along this direction, so it will be a z. Similarly, if you curling from a phi to a z, a phi to a z, a phi to a z, it will move towards the arrow. So in that way, by using the formulas or directly from the geometrically, you can find out the corresponding dot products and cross product between different unit vectors. Now once again, we have to consider the increment in the coordinate values. So that means you will consider this type of cylindrical box, not cylindrical box, a part of the cylindrical box. Increment along z. If you consider increment along z, so that is from z to z plus dz. This is the incremental part. This is the incremental part along z, that is dz. Similarly, we have to consider three coordinates, rho, phi, and z. First, we have started with z, then rho. Rho means you have to consider the radius. You see, this one is the rho. Cylinder with radius rho and another cylinder. So we are considering two concentric cylinders. One is radius rho, another is radius rho plus d rho. So this d rho, this is the increment along the radius of the cylinder. Next, phi. If you consider the cylinder up to this, say up to this the angle is phi, you see, up to this the angle is phi. Next, you are considering the cylinder up to this one. So difference between these two, it becomes the increment along d phi. So after considering this increment for three different coordinate axes in the cylindrical coordinate system, physically you have increased the radius by d rho, the height by dz, and the angle by d phi. But due to this increment, what will be the corresponding increment in the volume? If to find out the corresponding increment in the volume, we have to consider this particular cube. Now, from this figure, it is clear that what will be this incremental part? What will be this incremental part? You see, This is nothing but the increment in the radius, that is d rho. This is nothing but the increment in the height of the cylinder, dz. And what about this part? Is it only d phi? How we can find out this one? If this particular angle is very small, theta, this is r, then how we can represent this particular difference? Sorry, if it is d theta, is d theta, or theta, you can also write down theta. How we can write down this particular difference, angular difference?
R d theta.
R d theta, correct. R d theta. So in that case, R means ekhane rho. Along this axis it is rho, and the increment along the angle in the angle is d phi. So it becomes rho into d phi. So what will be the incremental volume? D rho dz, d rho dz, and this rho into d phi. So it is not like that directly you multiply dx into dy into dz in Cartesian coordinate system. In case of cylindrical coordinate system, for the increment of phi, this particular increment will not be directly only d phi, rather it will be rho into d phi. So incremental volume will be rho into d phi, then d rho into dz. Is there any doubt?
No, sir.
Okay. That is mentioned here, the incremental volume. Now different surface with differential area. Surface with differential area. Okay, before discussing about the surface about the differential area, it is better to discuss about the increment in length. Radius directly increment. What about the increment due to the phi? That is rho into d phi. This is the difference with the Cartesian coordinate system. So accordingly, you can find out the corresponding surface area along this x. This is one surface. This is another surface. This is another surface. So what will be the surface area of this particular one? It is d rho into dz, d rho into dz, d rho into dz, that is along the phi axis. D rho into dz, d rho into dz, this one. Next, what about this particular surface? One is d rho, another is rho d phi. So it will be rho d phi into d rho. Rho d phi into dz. So similarly, you can find out the another surface area. At that point is mentioned the increment. If this arm is rho, this arm is also rho, then due to the increment of d phi, this particular dimension will be rho into d phi. So this increment is not only d phi, rather it will be rho into d phi. So d phi is not the increment in length, rather rho into d phi is increment in the length. So once again, you have considered three unit vector, a rho, a phi, a z, and accordingly you have considered three different surfaces, ds rho, that means the unit vector a rho, ds phi, that means it is along the unit vector Fi, and this is another one. This is along Az. These unit vector are better represented in this particular figure. If you consider rho d phi into dz, rho d phi into dz, that means this particular surface, for this particular surface, what will be the unit vector that is normal to this surface? That means সেটাই হচ্ছে a rho. So you see that particular rho d phi into dz, and the corresponding unit vector is normal to this surface. So it will be, its surface area will be ds rho equal to rho d phi into dz into the corresponding unit vector. Similarly, ds phi means dz into d rho, dz into d rho, dz into d rho, dz into d rho. তার মানে আমরা বলতে পারি, we can say that this particular surface, for this particular surface, this arm length is d rho. What about this arm length? This dz. So it is d rho into dz. And what about the unit vector? The unit vector to this surface means that is a phi. Okay, that is a phi. Yeah. So it will be ds phi equal to d rho into dz into a phi. Similarly, this is the top on this top surface. The top surface, for this top surface, one side is d rho, one side is d rho. You see, one side is d rho, and another side is rho into d phi, and the unit vector is along z direction. So it is az. So the corresponding surface vector will be ds equal to rho into d phi into d rho, and the unit vector is az. Now, how we can write down this cylindrical coordinate system in terms of Cartesian coordinate system? Okay, or we can say how the Cartesian and cylindrical coordinate systems are related with each other. So once again, we have considered the cylindrical coordinate system, where the center of the cylindrical coordinate system is along the z-axis. These x, y, and z, these are three mutually orthogonal axes of the Cartesian coordinate system. Now, if this particular angle is phi, and this is the radius of the cylindrical coordinate system, radius of this particular cylinder, then these two components we can write down. This angle is phi, so this angle is also phi. So it becomes rho sin phi, rho cos phi. So what will be the value of x? X equal to x along x-axis. Along x-axis যে কম্পোনেন্টটা কি হচ্ছে এটা, that is rho cos phi. Along y-axis it becomes rho sin phi. What about z? Along z-axis it is itself z. So x equal to rho cos phi, y equal to rho sin phi, and z equal to z. Now inversely, how you can find out rho? Rho equal to root of x square plus y square. What will be phi? That will be tan inverse y by x. What will be z? That is z equal to z. So this first three that means we have written the Cartesian coordinate system. Cartesian coordinate system means x, y, z in terms of cylindrical coordinate system. Cylindrical coordinate means rho, phi, and z. In the second set, we have written the cylindrical coordinate system. Cylindrical coordinate system in terms of, it is cylindrical coordinate system in terms of Cartesian coordinate system. Okay. Now the transformation, how we can transform between these two coordinate systems. We can apply these equations, or you can derive these equations from the previous equations. That is, A rho will be ax cos phi plus ay sin phi. That is, we are writing the cylindrical coordinate system, that is a rho, a phi, a z. If you want to represent a vector A in Cartesian coordinate system, so its component will be a rho, a phi, a z. And we are writing the Cartesian coordinate system, cylindrical coordinate system in terms of Cartesian coordinate system. So it will be minus ax cos phi plus ay sin phi minus ax sin phi plus ay sin phi. And what will be az? Az will be equal to az. And the reverse is also reverse set is also given. That is, in this set we have written the Cartesian coordinates or Cartesian components in terms of cylindrical components. Ax equal to a rho cos phi minus a phi sin phi, ay equal to a rho sin phi plus a phi cos phi, and az equal to az. So this is nothing but the matrix representation of these equations, and this is nothing but the matrix representation of these equations. So to transform from Cartesian to cylindrical or from cylindrical to Cartesian, you have to use this set of equations, as well as you have to consider the geometry. You have to basically memorize the geometrical structure of the cylindrical coordinate system and the corresponding unit vector representation. Unit vector representation is very important to solve the problems related to the coordinate transition or coordinate transformation. Okay. So let's consider an example. A cylinder with radius of rho and length of L. Then you have to determine the volume enclosed, and also you have to determine the surface area of that volume. So for first one, if you have to find out the volume enclosed, simply we are considering a cylindrical cylinder. Radius of the cylinder is rho and the length of the cylinder is L. Length of the cylinder means basically the height of the cylinder. So how you can find out the volume? That is the integration of dV. There are three planes. One is rho, and then there is phi, another is z. Rho, what will be the limit of rho? The radius is given 0 to rho. What will be the limit of phi? Phi is entire 360 degree for a particular cylinder, 0 to 2 pi. The length of the cylinder is given, that is L. So what will be the limit of z? Z equal to 0 to L. So if you solve this, it will be pi rho square L. Next, you have to find out the surface area of that volume. Surface area of that volume. Surface area means কতগুলো surface আছে? For a cylinder, how many surfaces are there?
3 surfaces.
Yes, that means if we consider a container, there is a top, there is a bottom, and there is the side. So one by one, you have to consider 3 different surfaces. First, if you consider the side means one. So in that, to consider these surfaces, which one we are going to apply? I have already discussed about the surface vector. I have already discussed about the surface vectors. This one is the surface or the side of the cylinder. This is the top. This is the bottom. So top and bottom is same, will be equal. Only the difference is the surface. Surface means what is the unit vector? The unit vector is
Arrow.
A. So you have to consider this one. Rho d phi dz. To find out the surface area of the cylinder, you have to consider ds rho. And to find out the top and bottom, which one you have to consider? That is dsz. So one is rho into d phi dz, another is rho into d phi d rho. Now move to the see rho into d phi dz, rho into d phi d rho. What about the bottom? Bottom will be also same, because top and bottom are nothing but the top of the cylinder and the bottom of the cylinder, representing the same plane. Only the value of z is different. So now for this particular surface of the cylinder, from the surface vector, we have considered that is the ds rho, ds a rho. ds a rho means rho into d phi dz. d phi at dz আছে, তাহলে phi in the limit phi is from 0 to 2 pi, z is from 0 to L. Similarly, for the bottom, there is only rho into d phi. Rho is from 0 to 2 pi. What about the phi is from 0 to 2 pi and rho is from 0 to pi. For the top, that will be also same. So if you solve it, that will be the corresponding surface area of the volume. Next, another example. The surfaces, there are two surfaces. Okay. Rho equal to 3, rho equal to 5. Radius of this surface is more. Phi is 100 degree, phi is 130 degree. Z is 3, Z is 4.5. So the height, there is a difference in the height of the surfaces. One is 3, another is 4.5. First of all, you have to find out the enclosed volume. Enclosed volume by these two surfaces, not by the entire two cylinder. Rather, you have to find out the enclosed volume by these two surfaces. That means if you consider two containers with two different dimensions, the volume in between the two containers you have to find out. The total area of the enclosing surface, the length of the longest straight line that lies entirely within the volume, one by one. Why it is A? Anyway, I will check it. First, to find out the enclosed volume, we have already find out dV. What is the incremental volume dV? dV was rho into d phi, d rho into dz. So that is the expression of dV basically. So in this dV equation of the dV, you just put the limit. Rho is varying from 3 to 5. Phi is varying from 100 degree to 130 degree. Z is varying from 3 to 4.5. If you solve it, it will be 6.28. Point is that you have to convert it into radians. For this phi integration, you have to convert it into radians, because in the other two, we are using the values, magnitudes, so you can't integrate directly with the degrees. You have to convert it into radians. You will check the calculations. Next, the area. You see, one is the one, 2, 3, 4. So once again, one by one, you have to consider the corresponding surface vectors. Then you have to apply the corresponding limit, and if you calculate it, you'll be able to find out the area enclosed by the surface. What is the question of C? As per the question number C, activity C, the length of the longest straight line that lies entirely within the volume. So you have to first find out 2 points A and B. Then the difference between these two vectors will be the distance of the, or will be the corresponding length of the line. So A, the vector A, we can write down in terms of Cartesian coordinate. The vector is A equal to x, y, z. Now we apply the rules of transformation. We know x equal to rho into cos phi, y equal to rho into sin phi, z equal to z. So for the first cylinder, you find A. For the first cylinder, using this value of rho, phi and z. For the first cylinder, you see the problem, in the problem it is given z equal to 3, phi equal to most probably 130 degree, and rho is given. So using the value of rho, phi and z, first you find out x, y, z for one cylinder. Then you find out another point B on the another cylinder, that is with height of 4.5. Once again, you have to use these equations: x equal to rho cos phi, y sin phi, z equal to z. You see z equal to z, that's why it is 4.5. Y will be equal to rho into sin phi. Rho এর ভ্যালুটা বসাবে, sin phi equal to most probably for the second cylinder it is 130 degree. So accordingly you will be able to find out the 2 points. Point A is on cylinder A, point B, that is on the surface of cylinder B. Now if we consider 2 vectors, two cylinders are given. One is this, another is suppose this. We have to consider suppose this is the center of the coordinate system O, and first we are considering one point, this point A on cylinder, first cylinder. Another point we are considering on the cylinder B. Another point B we are considering on the another cylinder. So if we can draw a line from the center, it is representing one cylinder, one vector OA. If we draw this line, it will represent the another vector OB. The question is, what will be the maximum length of the vector between these two surfaces? So it will be the difference between these two. So B minus A. Or as per the direction, you can easily find out A minus B or B minus A. Is it clear? So first you find out the position of A in terms of Cartesian coordinate. You can easily find out it by using these equations. Then you find out for the second cylinder, that is the point on second cylinder. Then by just considering the vector addition, you will find out the difference between these two vectors. OA plus B minus A. Direction that. That will be the B minus A. Is there any doubt?
No, sir.
No, sir.
Okay, it's already 4:40. I think I will not be able to cover the spherical coordinate system. So I will stop at the end of the cylindrical coordinate system. Are you bored or are you enjoying the class? Enjoying the class. Is it true? Absolutely true?
Yes,
Yes,
sir.
sir.
Okay, thank you then. So on the next class, I will discuss about the spherical coordinate because it will not be possible to, it will take another half an hour. So better to just discuss this one, then stop. So this is very important example, how we can transform into the cylindrical coordinate system. A particular vector, see, a particular vector is given in Cartesian coordinate system, b equal to yax minus xay minus zaz. Okay, then how we can convert it into cylindrical coordinate system? Cartesian means x, y, z. Cylindrical means rho phi z. So we have to find out the b rho, b phi, and bz. So we can start with this one. What will be b rho? The vector b dot a rho. That is the unit vector for the plane with constant rho. That is, a rho is the unit vector to the plane with constant rho. Next, how we can find out b phi? That is b dot of a phi. So simply using this equation, y is outside the dot product, so it becomes ax dot a rho minus ay dot a rho, and in that case, if you consider the z1, it becomes a rho into az. What will be the, why we are not considering the a rho into az? Why we are not considering the a rho into az?
Z is same in both the coordinates.
No. Rho phi z, they are orthogonally
Orthogonal to each other, so dot product will be zero.
Will be zero. Dot product will be zero. That's why we are not considering the z component or dot product of a rho with the z. Similarly, we are again considering the b phi, that is b dot a rho, a phi, b dot into a phi, ax dot a phi, ay dot a phi. Once again, we are not considering the dot product between the a phi and az. Then to find out this b, same equations, we have once again it is written. What will be y into ax dot a rho? Ax dot a rho and ay dot a rho. Can you tell me? Anyone? Ax dot a rho and ay dot a rho. কিভাবে পাবে? See, these are the transformation equation. From we have written the cylindrical coordinate in terms of Cartesian coordinate. So if you consider the a rho into sorry, first ax dot a rho. Ax dot a rho. So if you perform the Ax dot A row, it will become cos phi. If you find out Ay dot A row, Ay dot A row, Ay dot A row, it will become sin phi. It will leave only the sin phi. So it becomes y of cos phi minus x of sin phi. Now you put y equal to rho sin phi, x equal to, charge is low. You just put the value of x equal to rho cos phi, so it will cancel. So b rho becomes 0. Next, what about the b phi? B phi equal to these equations we have to consider, that is ax dot a phi. Ax dot a phi. Ax dot a phi. You have to consider the second equation. Ax dot a phi. It will be only sin phi. That is minus sin phi. It will be minus sin phi. Similarly, ay dot a phi. Once again, you have to consider the second equation. Ay dot a phi. Ay dot a phi means it will leave only the cos phi. So it becomes minus of y sin phi minus of x cos phi. Now you put the value of y and x. Y and x. Y equal to rho sin phi. Y equal to rho sin phi. That means it becomes rho into sin square phi. X equal to, we know x equal to say rho cos phi. So it becomes rho into cos square phi. So minus common relay, rho sin square theta plus cos square theta is 1. So b phi becomes only rho. Now you write down the vector b in terms of Cartesian, in terms of cylindrical coordinate system. So if you write down the b in terms of cylindrical coordinate system, you can write down that vector b, that is equal to b rho into a rho, where a rho is the unit vector. Next is the b phi into a phi is the unit vector, plus bz into into the az. Az is the unit vector along z axis. Now you see, we have find out b rho. B rho equal to কত বেরিয়েছে? B rho equal to 0. What about the b phi? B phi is equal to minus rho. And what about the z? Bz? What will be bz?
Z.
Bz will be equal to z, because in both the coordinate
It's same
system,
for both the
Same.
coordinate system.
yes. So it becomes the first term is 0, the second term becomes minus of rho a phi, and third term is z into z. So in that way, easily using the transformation equations, you can convert the Cartesian representation or Cartesian coordinate into cylindrical coordinate, or cylindrical into Cartesian coordinates. So next, the spherical coordinate, I'll take it on the next class, because it's almost nearly 2 hours. এরপরে বেশি নিলে তোমাদের উপর টর্চার করা হয়ে যাবে, তার থেকে বড় কথা মাথায় ঢুকবে না। Anyway, so is there any problem to realize the spherical, not spherical, the Cartesian and cylindrical coordinate system? and the related examples and the examples. How many are there? Only 24. Now this is the time of attendance, so you should switch on your video. One by one, Abhishek.
Yes, sir, present.
Abhishek is present. Next, Alamgir. Alamgir.
Yes, sir, present.
Anirban.
Sir, present, sir.
অনির্বাণ ভিডিও কোথায় গেল?
Sir, I don't have a camera. Sir, it's easier for me to join from the computer, so I always join from the computer, sir, and I don't have webcam.
অর্চনা কুমারী.
Yes, sir, I'm present.
অর্চনা, is there any problem?
No, sir.
Last class you were talking about some doubts regarding the coordinate systems.
Yeah, I had a doubt on slide number 34. Can you share that once?
Slide number 34.
Yeah. Question number 4. That was.
Question number 4.
Yeah, question 4.
Example 4 though.
Yeah, example 4, slide number 34.
You tell me what is your doubt?
In that volume equation, in that row, will we put 3 or 5? I think 3 should be put because that's lower than 5. So.
Z equal to 3 to 4.5.
No, I'm asking that in volume equation, we have rho d rho into d phi into dz. So what we
Yes.
will put, so in the value of rho, what we will put, 3 or 5?
You have to put 3 to 5.
No, 3 to 5, that's d rho value. I'm asking about rho, what we will put.
Oh, row value. I think
Yeah.
it will be 3.
Okay.
Okay.
Yeah.
You can check try to solve it. I did not show the entire calculation. Okay.
Okay.
Try to solve it. If you face any problem, I will help you.
Okay.
Okay. Next is Arijit Chakraborty. Okay. Next, Orko Maikov. Okay. Next, Orko Provo.
Present, sir.
Orko Provo. ভিডিও কি হলো দেখতে পাচ্ছি না। নেক্সট ওকে অর্ণব
Present, sir.
অর্ণব। নেক্সট হলো দীপ কুমার
Present, sir.
গৌরাঙ্গ
Present, sir.
রূপম ঘোষ। রূপম প্রেজেন্ট অর অ্যাবসেন্ট?
Sir, ও থাকে না স্যার,
হ্যাঁ
ও নেই, আমাদের
থাকে না।
ডিপার্টমেন্টেই নেই।
কিন্তু কমপ্লিটলি ছেড়ে দিয়েছে কি? তাহলে আমি ইয়েলো করে দেবো।
হ্যাঁ স্যার, কমপ্লিটলি ছেড়ে দিচ্ছি।
হ্যাঁ স্যার, কমপ্লিটলি।
নেক্সট শাহানা।
Yes, sir.
শাহানা প্রেজেন্ট। সায়ন
প্রেজেন্ট স্যার।
সায়ন নদী। সায়ন ঠিক আছে। সায়ন নদীর
প্রেজেন্ট স্যার।
হ্যাঁ ঠিক আছে। সায়ন নদীর হলো। নেক্সট শ্রাবণী।
Present, sir.
শ্রাবণী। শাশ্বত। শাশ্বত,
Present, sir.
ওকে। নেক্সট সৌভিক, সৌভিক চ্যাটার্জি,
Absent.
অ্যাবসেন্ট। সৌরদীপ, সৌরদীপ দাস, সৌরদীপ,
Absent, sir.
ওকে। স্বস্তিক কুমার,
Present, sir.
কুমার, তর্পণ,
Present, sir. Yes, sir.
তুহিন,
Present, sir.
তুহিন দাস। নেক্সট এবার একে একে বলবে যারা নিউ জয়েন করেছো ফ্রম বিএসসি, 1 by 1 নাম বললো আর ভিডিওটা অন কর।
Okay, sir.
Sir, I am Rup Kumar বিশ্বাস.
রূপ কুমার বিশ্বাস, ধর আমাকে নোট করতে হবে। রূপ কুমার বিশ্বাস। রূপ কুমার, তুমি কোন কলেজ থেকে এসছো?
বঙ্গবাসী মর্নিং কলেজ,
বঙ্গবাসী মর্নিং। কোথায় থাকো?
চন্দননগর রামকৃষ্ণ আশ্রম।
হ্যাঁ?
চন্দননগর রামকৃষ্ণ আশ্রম মাঠ।
চন্দননগরে থাকো?
হ্যাঁ স্যার।
আচ্ছা। নেক্সট হচ্ছে, নেক্সট কি আছে বলো?
Sir, Indrila Chatterjee.
ইন্দিরা চ্যাটার্জি। তুমি কোন কলেজ থেকে এসছো?
Sir, Vidyasagar College.
বিদ্যাসাগর। ইন্দিরা চ্যাটার্জি, OINDRIL।
Sir, single L, sir.
হ্যাঁ, একটাই লিখলাম, সিঙ্গেল উইন ডিলার। যেটা দেখা যাচ্ছে তোমার নাম এখানে, সেটাই তো?
হ্যাঁ স্যার, হ্যাঁ স্যার।
কোথায় বাড়ি তোমার?
বেলঘড়িয়া স্যার।
বেলঘড়িয়া। নেক্সট,
Sir, Nirupama Mitro.
নিরুপমা, NIR। নিরুপমা, তোমরা আমাকে মেল আইডি গুলো পাঠিয়ে দেবে ইন্ডিভিজুয়াল।
আচ্ছা স্যার।
তুমি কোন কলেজ থেকে এসেছো?
স্যার, ভিক্টোরিয়া কলেজ।
ভিক্টোরিয়া মানে তো আমাদের পাশেই, যেটা তাই তো, রেজিস্ট্রেশন কলেজের আগে আগে।
হ্যাঁ হ্যাঁ হ্যাঁ।
কোথায় বাড়ি তোমার?
স্যার, খড়দা।
নেক্সট কি আছো? আর কেউ?
Sir, Subham Kumar Gupta.
শুভম, কোন কলেজ থেকে?
Yes, sir.
Which college?
Vidyasagar.
Vidyasagar.
Yes, sir.
Where do you stay?
Sir, Dum Dum.
Okay. Next, is there anyone? আর কেউ?
না স্যার, আর নেই।
1 2 3 4. Okay.
Sir.
স্যার আরেকজন আছে, সে জয়েন করেনি।
তো অনেকেই জয়েন করবে, আর লিস্ট তো বোধহয় 16-17 জন জয়েন করে ল্যাটারাল থেকে।
স্যার, আমার একটা প্রশ্ন ছিল স্যার।
হ্যাঁ বলো, বলে দিন।
স্যার, বলছিলাম যে আপনার যে একটা আগের যে পিপিটিটা আপনি বললেন যে আপনার দেওয়া রয়েছে, ওটা আমি দেখেছি। তো ওখান থেকে কয়েকটা ডাউটস হয়েছে, তো ওটাকে আমি নেক্সট ক্লাসে আপনার থেকে জিজ্ঞেস করে নেবো কি, নাকি আপনি সেটা রিলেটেড কোনো ক্লাস নেবেন আবার?
কোন সেকেন্ড ডে পিপিটি আর ফার্স্ট ডে পিপিটি?
স্যার, একটাই পিপিটি আমি পেয়েছিলাম অ্যাকচুয়ালি ওখানে গ্রুপটাতে। ইএম এর উপরে বেসিক এর একটা।
আমি দুটো পিপিটি শেয়ার করেছি না লাস্ট যে দুটো ক্লাস নিয়েছি?
হ্যাঁ স্যার, হ্যাঁ
স্যার,
স্যার।
আমার তাহলে ওটা মোস্ট প্রবাবলি কোনো কারণে খোলেন।
একটা পিডিএফ ফরম্যাটে ওখানে আছে, আর একটা পিপিটি।
হ্যাঁ স্যার।
ওই পিডিএফ ফরম্যাটে দিয়েছিলাম না তো, পিপিটি শো যেটা ফরম্যাট থাকে সেই
একটা
ফরম্যাটে
পিপিটি ছিল, ওটাকে আমি পরে মানে পিডিএফ এ কনভার্ট করে ওটাই আপলোড করে দিয়েছিলাম। ওটা মানে পিপিটিটার সাইজ অনেক বড় ছিল বলে আপলোড করা যাচ্ছিল না।
হ্যাঁ হ্যাঁ হ্যাঁ, ওটা একটু অতই পিকচার ইনসার্ট করা হয়েছে তো অনেক সাইজ বেড়ে গেছে। কিন্তু এখন এগুলো তো হবে না, এগুলোতে অন্যভাবে করছি, সাইজ কমই থাকবে। ঠিক আছে, তাহলে তুমি নেক্সট ক্লাসে করে নিও। হ্যাঁ
আচ্ছা
আর
স্যার।
জানি না, এখন তো 15 তারিখ 16 তারিখ থেকে তো বলছে, আবার যদি অফলাইন শুরু হয়ে যায় তখন কি মোডে কি ক্লাস হবে কিছুই তো বুঝতে পারছি না।
স্যার তখন কি কলেজে গিয়ে আমাদের ক্লাসেস মানে
আমিও
offline?
জানি না, তুমিও যেখানে আমিও সেখানে, সেই অবস্থা।
আচ্ছা স্যার।
এন্ড অফ ডিসেম্বর হয়তো। তোমাদের এই তো ল্যাটারাল এন্ট্রিদের জন্য তো ক্লাস ফুল ফেজে শুরু করা যাচ্ছে না, সমস্যা তো এখানে।
স্যার তাহলে এক্সামস হতে হতে কতদিন, মানে সেমিস্টার এক্সাম হতে হতে তাহলে?
ইন জেনারেল ডিসেম্বরের শেষে বা জানুয়ারিতে হয় তোমাদের থার্ড সেম।
আচ্ছা স্যার।
বাকি সব ক্লাস শুরু হয়েছে তো সায়নদীপ?
না স্যার, এখনো সার্কিট থিওরির সব ক্লাস শুরু হয়নি।
ডিসি স্যার নিচ্ছেন?
হ্যাঁ, ডিজি স্যার নিচ্ছেন।
ঠিক আছে ঠিক আছে, ওকে তাহলে আমি আজ তো থার্সডে, আমি তো বলেছি থার্সডে নেব, এখন দেখা যাক নেক্সট উইকে কি ডিসিশন হয়। আশা করি নেক্সট থার্সডে অনলাইনে নিতে হবে।
স্যার নেক্সট থার্সডে তো মানে কালী পুজো আছে মনে হয়।
ও
হ্যাঁ স্যার, ওই দিন তো ছুটি।
ঠিক আছে, তাহলে পরে যখন পাবো, এমনিতেই তো এটা মানে ল্যাটারাল যদি না আসে আমাকে তো আবার রিপিট করতে হবে না, ততদিনে জয়েন করে যাক। তাহলে আফটার কালী পুজো যে ক্লাসটা পাবো সেখানে আমি স্পেরিক্যালটা শুরু করব। স্পেরিক্যালের একদিকে ভালোই হলো, স্পেরিক্যালটা পড়াবো, প্লাস হচ্ছে ওই ডাইভারজেন্স কাল এগুলো বেসিকটা ডিসকাস করা আছে, ওগুলো করে দেবো। তো এমনি ওভারঅল বোঝা যাচ্ছে তো?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
প্রেজেন্টেশন খুব ফাস্ট মনে হচ্ছে কি না, কি ঠিক স্পিড ঠিক আছে?
স্যার ঠিক আছে।
স্যার ঠিক আছে স্যার।
ঠিক আছে,
ঠিক আছে স্যার।
কিছু প্রবলেম হলে বলবে।
Sir, I had a
Okay,
doubt
sir.
that
অর্চনা,
yeah. I wanted to ask that if we had Cartesian coordinate system with us, then what was the necessity to introduce a new coordinate system called as cylindrical? I mean, what is the need?
Good questions. With the simple Cartesian coordinate system, it is difficult to represent the vector in 3D form. It will be more clear when we will deal with practical problems associated with the electromagnetic fields. Not only in the electromagnetic fields, in 3D representation, it is easier to particularly represent with the spherical coordinate rather than cylindrical and Cartesian. That's why one by one we are moving from Cartesian coordinate to cylindrical to spherical. And in some cases spherical has in some cases Cartesian has some also advantage. So depending on your applications area, you have to choose which coordinate system you have to apply. Am I clear?
Okay, but whatever can be solved in cylindrical can also be solved with Cartesian system.
Yes, that's also true. That is also true. But it will
Okay.
take more time and more, it will be lengthy procedure.
Okay.
So for the simplicity, we are moving from one system to another. That is what. Okay, so that's all. কে বলছে এটা রোল নাম্বার? Shovik Chatterjee, EC435. Sir, I don't have a mic yet, so could not give the attendance or microphone. Shovik, এইমাত্র আমি অ্যাটেন্ডেন্স বন্ধ করলাম। ভিডিওটা তো আপনি করবে? Shovik, yes, Shovik Chatterjee. সায়নদীপ বললেন, আর লাস্ট দিন তোমরা বললেন না সৌভিক ছেড়ে দিয়েছে নাকি?
স্যার দুটো সৌভিক চ্যাটার্জি আছে স্যার, একজন আছে আর একজন নেই, স্পেলিং দুটো আলাদা।
এই সব।
স্যার বিএইচআই কেটা আছে স্যার, ভিআইটা নেই।
ও তাহলে দাঁড়ানো, সৌভিক আরেকটা নাম অন্য জায়গায় আছে, এটা ইয়েলো করো, আরেকটা নাম কোথায় গেল তাহলে? পাশাপাশি তো থাকার কথা সৌভিক। হ্যাঁ সৌভিক, হ্যাঁ হ্যাঁ ঠিক আছে ঠিক আছে, ইউ হ্যাভ অ্যাটেন্ড দ্য লাস্ট 2 ক্লাসেস অলসো। ওকে ওকে।
স্যার নেক্সট থার্সডে তাহলে ছুটি তো?
হ্যাঁ অফিসিয়ালি ছুটি থাকলে ছুটি ক্লাস নেব না, যদি তেমন বুঝি আমি যদি অন্য কোনো ক্লাস নিতে ইচ্ছে হয় এর মাঝে, তাহলে আমি তোমাদের তো এমনি ফ্রি টাইম তো আছে তাই তো?
হ্যাঁ স্যার।
হ্যাঁ সেই বুঝে আমি তাহলে কত ডিসকাস করে নেব।
স্যার আপনাকে আমাদের মেল আইডি গুলোকে মেল করে দিতে বললেন না?
হ্যাঁ হ্যাঁ
স্যার
বেটার হয় একসাথে সবগুলো পাঠিও। হ্যাঁ
আচ্ছা
একটা
স্যার।
একটা করে ইন্ডিভিজুয়ালি না পাঠিয়ে ধরো এই 4-5 জন যে জয়েন করেছো 4-5 জনের ট্যাগ লিস্ট একসাথে পাঠাও।
স্যার আপনার মেল আইডিটা নেই আমাদের কাছে, তো সেটা আমরা কি তাহলে সায়নদীপকে পাঠিয়ে দেবো, ওকে আপনাকে পাঠিয়ে দেবেন সব করে?
সায়নদীপকে বলো না, ও দিয়ে দেবে, আমার মেল আইডি শেয়ার করে
ওকে
দেবে।
স্যার।
ওকে স্যার।
আজকে যেটা যে ক্লাস লিংক পেয়েছো সেখান থেকেই তো পেয়ে যাবে।
হ্যাঁ স্যার, ওকে স্যার, ঠিক আছে স্যার।
আজকে যে ক্লাস লিংক পেয়েছো সেখান থেকেই পেয়ে যাবে, ওটাই আমার ইউনিভার্সিটি মেল আইডি, ওটা থেকে পেয়ে যাবে।
ঠিক আছে স্যার।
ওকে
ওকে স্যার। বিএসসি যারা আছে একটুখানি ওয়েট করো।
আচ্ছা।